Section 2.2, direct variation. The formula for direct variation can be written as y equals k times x, or k equals y divided by x. In this case, k is the constant of variation. So the relationship between the variables y and x is constant, meaning that if you take your input x and multiply it by your k value, or your constant of variation, the output is y. And it's the same k value for every input of x to get each of your inputs for y, or outputs for y. This particular formula is really helpful when you're trying to figure out what your constant of variation is, or testing to see if you're dealing with a direct variation. So here we want to identify direct variation from tables. It says for each function, determine whether y varies directly with x. If so, what is the constant of variation and the function rule? So we're trying to figure out if y varies directly with x, and we need to figure that out by testing to see what the constant of variation is for each ordered pair. So keep in mind what we saw in the previous slide. We know that k, or the constant of variation, is equal to y divided by x. So essentially that's what we're going to test here for each of these values in these tables. So for the first one, we know that if we're looking for k here, it would be 2 over 1, which would be 2. For the next set, we've got k equals 6 over 3, which is also 2. And then last but not least here, we've got 8 over 4, which is also 2. Notice that all the values here are 2. So this is a direct variation, and our constant of variation is 2. And then when we want to write our function rule, we're just writing our direct variation equation. Y equals, and now we'll use the actual k value, 2x. We'll do the same thing for table B. We're going to test and find the k value. So k equals 4 over 1, that's 4. K equals 8 over 2, which is 4. Here k equals 11 over 3, which I know for a fact does not equal 4, so this is not direct. These tables are just written sideways now, but you can do the same thing. So I recommend pausing the video, figuring out your k value for each one, and then writing your function rule and determining your constant of variation. So pause the video, give it a shot. When you're ready, unpause the video to see the answers. For problem A here, we see that all of our constant of variations, when we test them, are -7. So this is going to be direct. Our k value is -7, and then our function rule would be y equals -7x. In question B here, we tested the first group, and we got 5 divided by 2 is 2.5, so k would be 2.5 here. We move on down, we've got 7 divided by 3, which is not 2.5, so I can stop there because now I know this is not direct. Since the two k values did not match, here we want to identify direct variation from equations, and we're determining if y varies directly with x, and if so, what is the constant of variation. To determine if we have a direct variation from an equation, we're essentially looking for our direct variation equation to be in this form, y equals kx. And if it's not, then we need to rewrite it so it is. So if we look at example A here, to get the y by itself, I divide by 3. I'm going to get y equals 7/3 x. Well, that fits the format, so this is direct. And our k value in this case is 7/3. Question B, same idea. We want to get the y by itself. Divide by 7. We're going to get y equals 2x plus 1. This is not direct. We have this added piece here, so this one doesn't work. Question C, same idea. We're going to get y by itself. To do that, we'll move the 5x by subtracting it. 3y equals -5x. We're going to go ahead and divide by 3. We're going to get y equals -5/3 x. So this is a direct variation, so it's in the right form. And our k value here is going to be -5/3. And then last but not least, we've got y equals x over 9. In reality, we can rewrite this as y equals 1/9 times x. So right now we can see that this is in the right form. So this is also direct. And our k value is going to be 1/9. So now we're going to use a proportion to solve direct variation. So in this first problem, it says suppose y varies directly with x, and when y is not, and y equals 9 when x is negative 15. What is y when x equals 21? So the idea here is we know there is a direct relationship between x and y. There is a constant of variation, and because of that, we can set up a proportion to figure out what the value of y would be given a different x value. So ideally, what we're going to do is we're going to take the first two values we have, the y and the x, and we're going to stack them like this. And we're going to set that equal to the new y we're looking for. I'm just going to put new y over the new x they gave us. And we're going to use proportions to solve this. So ideally, we've got 9 over negative 15 equals y over 21. And then the goal with any proportion would be to cross multiply and divide as needed, and we should figure out what y equals. So we would cross multiply, we get negative 15y equals 9 times 21. Then we'll divide by negative 15 on both sides, and we're going to get that the y value in this case should be negative 12.6. Problem 2 says, suppose y varies directly with x, and y equals 15 when x is 3. What is y when x is 12? Alright, so we're going to set up the proportion again like we did before. We know that y is 15, x is 3, so 15 over 3 equals, we're looking for y again, so we're going to say y over 12. So now we just want to cross multiply. That's 3y equals 180. Then we're going to divide by 3, and we get y equals 60. So here we're going to use direct variation to solve a word problem or a real-life situation. So a salesperson's commission varies directly with sales. So we know we're dealing with direct variation because it varies directly. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So the first thing we should do is probably set up a direct variation expression for this. So we know in this case, commission varies directly with sales. So let's let commission be C. It's going to equal the constant of variation, whatever the rate is here, times sales. So for this problem, we already know in this case, we know for $1,000 in sales, we get a commission of $85. So this is going to help us find K. So we're going to have 85 equals K times 1,000. The goal here is now to solve for K, so we'll divide by 1,000. And in this case, we're going to get our constant of variation to be equal to 0.085. So now taking that constant of variation, we can now solve the second half of this problem. Because now our equation is C equals 0.085 times S. Well, if we have $2,300 in sales, we should be able to figure out what the commission is for that. So C equals 0.085 times 2,300. Now we just need to multiply that out, and we get that our commission equals $195.50. There we go. All right, next question, same idea. The number of calories varies directly with the mass of cheese. If 50 grams of cheese contains 200 calories, how many calories are in 70 grams of cheese? So in this case, we know calories varies directly with mass of cheese. So we'll write our equation. Calories equals the constant of variation times the mass of the cheese. because we know this is direct variation again. So in this case, we've got 200 calories equals K times the 50 grams of cheese. We'll divide by 50, and we're going to get our constant of variation is just 4 in this case. So now taking our new constant of variation, we've got C equals 4 times M. They want to know how many calories are in 70 grams of cheese, so we're just going to plug in 70 for M. And we're going to get that there are 280 calories in 70 grams of cheese. All right, and now we're talking about graphing with direct variation. And graphing with direct variation, fairly straightforward. You learned a lot about graphing with slope in Algebra 1. This should go by pretty quick. So here we have y equals 3/4 x, where the slope is 3/4. But with the direct variation equation, all you need to remember is this particular graph is going to start at 0, 0, because there is no c value at the end of this slope-intercept form. So we'll start at 0, 0, and from here we'll apply our slope. Up 3, right 4. Up 3, right 4. If we want some additional points, we can go backwards. We can go down 3, left 4. Down 3, left 4. And then to draw our line, we'll just connect the dots. Question B, same idea. We know that this graph is going to start from the point 0, 0, or the origin. Our slope in this case is -2 or -2/1, which means we're going to go down 2, right 1. So we go from this point down 2, right 1, down 2, right 1, down 2, right 1. We do this until we have enough points. And then we just connect our points to draw our line. And so this is our line for the direct variation equation given.